Hello guys, welcome back to my channel again. Today we are going to tackle this gate, logic gate, and it's the last gate in this series. As I told you previously, logic gates are basic building blocks of digital circuits. When you say digital circuit, what do you mean? What do you mean by the word digital? I told you before, digital means 0 and 1, and 0 means low, means not. Like when you switch off the current, then it's 0, and when you switch it on, then it means on, it means it's 1. So 0 and 1, this is what is referred to as digits, digital, zeros and ones, and it's used to represent this type of circuits. Electronic circuit, as it's defined, it is an electronic circuit with one or more input but one output. So before we proceed, I've already shown you this. I like to show you the diagrams for it and the symbols for it. For example, this is a symbol for OR gate is shown here. This is simple. We have a simple circuitry for it. Like we have the output here. We have the input from here. It's light actually. Light is the output, and these are the switches. And yeah, it's quite simple. And there's a truth table for it is here. One is 0, 0 is 0, one is 1, 1, sorry, it's just the opposite. One is, let me see from here, one is 0, 0, one is 0, 0, then is 0, one is 0, 1, then is 1, one is 1, 0 is 1, and 1, 1 is 1. This is what we call the truth table. Means if both switches are off, then the output is off. And if say A is on, off, and B is on, then it's on. And if say A is off and B is on, then it's 1, and A is on and B is off, it's 1. And if both are on, then it's on. It's called an OR gate. Means one of them has to be on for an output to be there. Okay, so I've constructed the circuit because it's not easy to do it under camera. Sorry, the lighting is so poor. It's not easy to do it under camera. Here I have the 9-volt battery. I have jumper wires, couple of jumper wires. I have 3 resistors, 220 ohm resistor. I have 1 LED, and I have 2 transistors, yeah, and a breadboard. These are you required to do this. Actually, these circuits are very important because all these electronic devices they use these logics. Logic in the sense that is an intelligible way to arrange this in order to achieve a certain output. Like in this case, we are having OR gate. One of the input has to be on for the output to be there. Like previously we did AND gate, we did NOT gate. So I'm going to demonstrate to you this, but one wire as usual has come off. I have to insert it. So we have the negative here, this black one, and the positive, this one just come out. I'm trying to put it back. So, yeah, I've managed to put it back. So you can see I have this resistor here, which is connected to the positive part of this side where the power is flowing. Current flows from positive to negative, but the electrons flow from the negative to the positive. So we have this. We don't put direct to the LED because LED can burn off, so we use a resistor here which is connected to the LED here, this LED, which is also in turn connected to the VCC of the transistor. We have two transistors which are connected by these jumper wires from here, and then we have the VEE, means the ground. So see, now can I turn this thing for you to see? Bring it closer. It's quite complex. So just build it. Okay. So suppose, see, for example, what I'm talking about. I'm going to press one switch. Yeah. Means high. Both now the LED is off because both are off. 0 0. The truth table I showed you. I want to press one of them to see what happens. So I press this one. You see the LED comes on. See, the LED is on. Yeah, but the other one is off. One of the input is off and one is high, and the LED is high, and then off. Let me press the other one also. Let's name this A and B. So A was high, B was low, and it was on. Now I'm going to B as a low, as high, and A as low. So let me go here. See, it's on. So B is high, A is low. Okay, this is a truth table that I've shown you. Now both, I'm going to press both. It's on. See, it's on. Either of these has to be on for the LED to be an output. The output doesn't necessarily have to be this. It can be anything. So when you build these things, the output can be anything. But in this case, we are using an LED. So it's called OR gates. It's used in these things, in computers. This is not the only gate. Gates are many. I've told you before: AND gate, NOT gate, NOR gate, NAND gate, XOR gate, XNOR gate. You see, but the three basic ones are those on AND gate, NOT gate, and OR gate. Basic, all are important. Yeah, man. So this is about digital circuits. I hope you understand it now. And you might be wondering, what is this? Like, for example, what are the zeros and ones? Zeros and ones are very important because we have the scales that are set like ASCII, American Standard Code of International Information Interchange, I guess, ASCII, or Unicode, which are used to convert these. They all appear in digitals because we are dealing with digitals. Computer is binary. I mean, digital circuits is binary, sorry, zeros and one. And from these, all the circuits are built like chips. For example, when you say data sheet of a chip, what are the chips? ICs. They comprise of these things. So that's how important they are. The circuits are built from here. The logics, they use logic, the intelligible way. These circuits are arranged in order to get a certain output. Yeah, man. Thank you for watching the last for this time. Maybe in future we'll do others. But for now, I think we'll conclude with this thing today. Oh man, one is coming out. No. But yeah, it's still on. Yeah. So we conclude our series today with this one, with two resistors here which are connected to the switch buttons, and one here, and that's it. Thanks for watching. Hope you now have some deep knowledge about what digitals are and what electronic circuits are. You know what is a circuit. A circuit is where electrons flow, and you get light from there in terms of photon. I mean, you know, that's technical. When the electrons flow, what happens, and how does light come about? And yeah, so a circuit has got to be complete in order for an output to be there. Unless it's complete, if it's not complete, then the output will not be there. Okay, man. Thanks for watching. Please like, share and subscribe. See you again in the next one. Bye. Comment also. Bye.